I am going to talk about integration, and I'm going to think about what is it actually for. So in order to do this, we first of all need to think about differentiation and what's that actually for, and how do we represent it visually, and hopefully from there we can think about what integration is and how we can represent that visually. So, differentiation, well, what are we actually doing? If we're differentiating something, we're finding the rate at which something is changing. So differentiation is just simply the rate of change, and on a graph, that is represented via the gradient. So if we differentiate something, we find the derivative, we are finding the gradient of that thing, whether it be a function, whether it be a line, whether it just be a point, we are finding some form of gradient. When we look at the integral, what we are doing is we are finding the total area of that thing. So it's the total area, or the total change, sorry, might be a better way of putting it, the total change, not the rate of change. So therefore, if we're looking at the total change, we would represent that on a graph as the area. And this is really prominent whenever we look at variable acceleration. If we think about a velocity time graph, well, the area underneath a velocity time graph we know is called the displacement, and the gradient of a velocity time graph we call the acceleration. And we know that they are linked in some way, and that way that they're linked is to do with the derivatives and the integrals. So, what I do to remember this is when I think about an integral question, although it's not directly linked to the area, there are some subtleties which we'll talk about throughout the next few examples, which is slightly different. We can think of finding the area as to integrating functions between certain bounds. So, if I was to approach an area question, I would be trying to think about these certain things that I want to do. So, for area questions, I'm going to put down 3 points, and I'd like you to make notes on these too. So, when I'm ever asked an area question, I want to sketch it. If it's tricky, draw a picky. Every single time, I'm going to sketch it. The next thing I'm going to do is I'm going to identify my integral. I'm going to identify what I'm integrating. I'm going to identify what bounds that I'm stuck by. So I'm going to identify my integral. And the last thing I'm going to do is I'm going to combine and construct. I'm going to combine my integrals if I have more than one, and I'm going to construct what my total area would be, because I could get some negative space, I could get some positive space, and I need to construct that final answer for the total units that are covered. So my last section is combine and construct. And I like to think of this as my area, and my integrals is always SIC, S-I-C. I love an abbreviation, so I always think for area questions, I'm going to think about SIC. So, let's put this into practice. I've got a question here. Find the area bound by the curve and the x-axis for y equals 3x subtract x squared. I'm just going to draw my axes because my first step is sketch. And I want to just know, what would this look like? So, I want to know, what does 3x subtract x squared look like? So in order to do this, I need to first of all work out what order the polynomial is, and it's an x squared order. So it's going to be some parabola. It's negative, so it's going to look like an upside down parabola, like this sort of shape. So the next thing I need to know are the roots. Looking at this, it actually factorizes quite nicely. I can take an x out, and that leaves me with 3 subtract x. So my roots are going to be x equals 0 and x equals 3, respectively. Just from this. So it's going to go through it here, and let's call this 3. So I can just draw my parabola, and if I want to find the area bound by the curve on the x-axis, the area that I'm looking at is just going to be this area inside here. So this is what I want to find. Okay, this is 3, so this is 0, and this is 3. So to do this, what I'm going to do is I'm going to need to integrate this, except for I'm going to have to integrate between these certain values. So I'm going to start off, and I'm going to just write down my function of y equals 3x subtract x squared, and when I integrate this, I'm going to end up with the integral of 3x subtract x squared with respect to x, but that's going to be bound by some region. So my area is going to be equal to the integral of this bound by the regions of the curve on the x-axis. Well, the curve on the x-axis is 3 and 0. So to do this, my area, and I'm going to swap to square brackets and just do my integration. Well, 3x squared over 2 subtract x cubed over 3, and this time it's between 3 and 0. I'm getting there in terms of I have now some information for this graph which I can use, but what I need to do is actually apply the limits of what I'm doing, and my limits are 3 and 0, so when I apply them, I'm just substituting in those values. So what I'm going to get is by substituting in the value 3, I get 3 times 3 squared over 2, subtract 3 cubed over 3, that's by substituting in my value of 3, and then subtracting, well on this side I'm going to get 0 squared over 2, which is 0, subtract 0 cubed over 3, which is 0. So what I'm left with is 3 times 3 squared, which is 27, over 2, subtract 27 over 3. I have a common factor, I can take 27 out as a factor, and I'm left with a half, take away a third, and we know from our common denominators that a half take away a third is going to be a sixth, so I end up with my area to be equal to a sixth of 27. For this, I'm just going to simplify 27 over 6 again because it's got a factor of 3, and that's going to be 9 over 2, and we've got an area here, but we're not really given any units. Now, we could just write down that my area is going to be 9 over 2 units squared, or 4.5 units squared, but we can sometimes be given context. So what I'd like us to start writing down is being very specific with our language and saying that the area is 9 over 2 units squared. Just finishing it off with a sentence so it makes sense. Okay. So what I'd like you to have a go at is I'd like you to find the area of a finite region between the curve with the 20 subtract x squared and the x-axis, please. Okay. Once you've done that, the first step we're going to have to do is sketch this. So to sketch this, I'm going to factorize it, and we should find that we have a factorization of negative x, and then to make 20, I have to have positive 5 and positive 4. So it's going to be negative x plus 4, x plus 5, and when I expand that, I would get the value of 20, subtract 5x plus 4x, subtract x squared. We should have correctly identified that this is a parabola, which is going to go through at positive 4 and negative 5, so it's going to look like this. Whereas this is 4 and this is negative 5, don't worry about the scale, but we need an appropriate sketch, and I want to find the area of a finite region, so that must be this region at the top. I know this is going through at 20, I don't need to write it on. So I'm going to try and find this finite region here. Okay. The next step that you should have done was spotted that once we've got this equation, I'm going to need to integrate it to find the area. So my area is going to be the integral between my limits, which are 4 and -5, of 20 subtract x squared with respect to x. So applying this integral now is going to be 20x subtract, well, this is going to be x squared over 2 subtract x cubed over 3. And again, my limits are 4 and -5. So substituting in, 20 lots of 4, subtract, well, 20 squared over 2 is, and 20 cubed, oh, why am I saying 20, sorry, 4 squared over 2, apologies for that, 4 squared over 2, and 4 cubed over 3. And from this, I'm going to be taking away my value of -5. So 20 lots of -5, subtract -5 squared over 2, make sure that's in brackets, and subtract -5 cubed over 3. Again, I could just work these out by looking at my calculator, or we're just going to do a bit of a mental exercise now. So this is going to be 80 subtract 16 over 2, which is 8, subtract 64 over 3. Take away, well, 20 subtract 5 multiplied by -5 is going to be -100. This is going to be subtract 25 over 2, and this is going to be plus 125 over 3. So 80 subtract 8 subtract 64 over 3 is going to give me 152 over 3. And we're taking away -100 subtract 12.5 plus 125 over 3. That would be -425 over 6. As these are both negative, it's going to be 152 over 3. Add, and it's going to be 425 over 6. That gives me a final answer of 243 over 2. So when I come to write this, I would say that the area is 243 over 2 units squared. So, thank you for watching this video. I hope you found it a good introduction into definite integrals. We will be exploring these for a bit of a lesson on Monday. However, it's nice to just have a little introduction to what we're going to go through. So, thank you for watching, and I hope you enjoyed.